Well, hello friends. Welcome back to the program. Today we are going to continue working on Ladybird and taking issues from Shopify.com because there's no shortage of things to do here. So earlier today I fixed an issue with margin collapse in Ladybird, and that made the logo for the website show up, although it is a bit too large, as you can tell. So today we are going to make it more properly shaped, let's say. And I took a look at it here just before, and it is an SVG element with display block. And that is something that we haven't really supported very well. All the SVGs on the websites that we've been testing with so far tend to be display inline. So display block is something that we need to implement properly, basically. So that's what we're going to do today. So I'm going to take this SVG here and see if I can just like copy that into a text file. We'll call it ch.html. And that probably worked, actually. That's really cool. Okay, and then I'll just put a doc type HTML. We'll make a little style sheet here also where we say SVG display block. Okay, now if we try to open this up, it looks a little bit goofy. And I'll show you what it looks like in Firefox. In Firefox, block level SVGs behave like any other block level element in that it uses stretch fit sizing. So it just uses up the available width sans margins. So we need to implement whatever is missing here so that we get the same stretch fit behavior for SVGs. And if we switch the display to inline, it will probably look a bit better. Yeah, at least then it gets correctly positioned. Although if we load that in Firefox, it actually resizes with the available space as well. So I think we're still not correct. It just happens to look slightly better with display inline. So I think what we need to do here is calculate the aspect ratio, like the intrinsic aspect ratio of the SVG, and then use that so that when it's a block level element, then or rather when we want to stretch fit the element, then we can get the width from the stretch fit width algorithm, and then we can compute the height from the intrinsic aspect ratio of the SVG. But there's probably going to be a bunch of things that break when we start doing this. So we're just going to start poking at some end of it. And that will probably be figuring out the aspect ratio. So what we want to do is we want to do something with the SVG box, which corresponds to the SVG element. I'll show you the layout tree for something like this. Actually, let me put it into block level once again. The layout tree for an SVG like this has an SVG box corresponding to the SVG DOM element. And this is the sort of the viewport that the rest of the SVG is rendered into. So it has a size of 608 by 173.6 here. And if we look at the viewbox attribute of the SVG, it happens to have those exact numbers and like a little bit of floating point noise there. But we're basically using the viewbox as the intrinsic size, I think, and then always using the intrinsic size as the used size of the SVG element. So the SVG box has to be smarter about this. So let's see what it currently does. So We treat SVG elements as replaced elements in our engine, or the SVG box at least is a replaced box, which means that, or replaced boxes or replaced elements is an SCSS concept that just means that the behavior or the presentation of this element sort of falls outside the rules of CSS. And it's not completely true about SVG, but for something like an image, for example, if you have an image element that refers to a JPEG, CSS does not govern what pixels you see inside that image, right? It can affect it a little bit, but the pixels themselves come from some raster bitmap file. Anyway, the way that we handle replaced elements in our layout engine at the moment is that before we do layout on them, we tell them, hey, prepare yourself for replaced layout. And that just gives them a chance to, for example, load a JPEG. If this is an image box, it will go and try to decode a JPEG and figure out how big am I? You know, what are my natural dimensions? And here, what we do is we look at the width and height attribute if they are present. If they are, then we use those as the intrinsic width, height, and aspect ratio of the SVG element. For things that don't have a width and height attribute, we iterate over the contents of the SVG and I guess collect sort of the united bounding box of all the things inside of it. I think I wrote this like a long time ago. I don't know if that's necessarily even correct, but I think what we need to do is we need to check if there is a view box, because if there's a view box attribute, then that tells us the intrinsic aspect ratio at least. And I guess you could say that it tells you the intrinsic size as well. Although I'm not sure if it should. Let's see. View box. Intrinsic sizing properties. The intrinsic aspect ratio must be calculated using the following algorithm. Okay. If the algorithm returns null, then there is no intrinsic aspect ratio. All right, and the intrinsic dimensions are from the width and height sizing properties. If they are, either one is specified, the use value is the initial value. Oh, if they're not specified, then it's auto. Sure. Okay, so intrinsic dimensions come from width and height. And the aspect ratio comes from this algorithm here that starts with width and height. If they're both absolute values, then it's width divided by height. If there's an SVG view active, which we do not support yet, but it's probably something we should eventually get to, and then checks for a view box. Okay, so the purpose of this function really here, which while I was describing it, I forgot to mention, the purpose of this function really is just to determine the intrinsic size properties of a replaced box. So the intrinsic width, height, and aspect ratio. And I think if we look at image box, prepare for replaced layout, it also just gets the current image bitmap if there's an ongoing animation, and then just tries to define the appropriate intrinsic size properties based on the bitmap. Okay, so what we really want to do here is two things. So first, I'm going to link to this because this is important. Okay, so the intrinsic dimensions must be determined from width and height sizing properties. Width and height sizing properties. So they should come from CSS, actually, not from the attributes. That's kind of interesting. So how does that work? If you set the attributes, yeah, right. So if you set the width attribute or the height attribute on an SVG element, then we turn those into CSS properties anyway. So looking at the DOM content attributes here, it feels a little bit wrong. We should be querying the CSS computed style. So let's see if we can do that. So computed width is computed values width height. Okay, so if either one is not specified, it's auto. Auto and percentage lengths must not be used to determine an intrinsic width or intrinsic height. Okay, so if computed width is auto, no. If it's not auto, then let's see. Percentage lengths must not be used to determine it. Okay, so it can't be auto and it can't be a percentage. Percentage. So it can't contain a percentage. Then we're clear to do this. Yes. Okay. And then let's do the same for the height. Thank you, Copilot. That looks really good. And let's see. Yeah, and then it talks about bitmap image formats, but obviously this is not a bitmap image format. Right, so then it talks about the intrinsic aspect ratio. So that's the important part here. So I think we should just nuke all of this old gunk here. And we can nuke this thing as well. It's actually going to save us a bit of work, I think, because previously we would spend a lot of time like measuring everything inside of an SVG. Every time we would want to do layout, we would measure every little component of the SVG to figure out like what are the bounding boxes. And we can also just not do that and follow the spec algorithm instead. So if the width and height sizing properties, so if computed width is, what is it today? What can I ask here? If they're both absolute values. So if it's a length, width and height sizing properties, auto percentage length. I guess what I really want to check here is that it's a length. It has to be a length. Because if it's like max content or min content or fit content or one of those weird new sizing properties, then it's not an intrinsic width or height either, I think. Although the spec doesn't mention that, but that's my intuition, that what they're really asking for is like, do you have a non-percentage length? Because then we can actually use it. So if they're both absolute values, so if computed width, so this is my interpretation of being an absolute value. And that went a little too fast there, although it is doing what I wanted to do, but let's write it out this way. Return width / height. So set intrinsic aspect ratio. Although if the height is 0, that's not very good. It doesn't mention either of them being 0. I feel like if either of them is 0, then we don't have an aspect ratio. So we should probably check for that as well. $2px. Height. All right. If width and height not 0. Maybe we should factor this into a separate function, actually. Set intrinsic aspect ratio. Calculate intrinsic aspect ratio. Yeah, let's put that in a separate function. No, discard. Optional float, I guess. All right, and then we will just put that down here, let's say. And we want to just take this whole thing I started doing here. Okay. And this also comes from this stuff. It's a shame that like some of these older specs, they don't have as many hyperlinkable things. So yeah, like you have to link to the section. I like it in the newer specs. You can link to like individual little pieces and fragments and things. That's very nice. Okay, so let's set up these type of things. Height. All right. So they're both absolute values. And yeah, so return with height. Otherwise, return an empty optional. I think that's fine. Oh yeah, so since we're returning a ratio, the ratio doesn't need to be in CSS pixels. So I'm just going to convert these to, I guess we can do it here actually. Yeah. Okay. And then if we can't find anything, right. Okay, so if an SVG view is active, so this is a thing that we don't have at the moment, so we're going to put that as a fix me. And that will be something great to implement when we get there. But for now, we're just going to skip to step 3 here. If the view box is correctly specified. So DOM node has a view box, right? And the view box has a value. Why can't I do that? Because we don't have a const overload of the getter. That's fine. We'll make one. Here we go. Okay, and then I guess we can write it exactly as the spec does. Actually, that's fine. So if it is correctly specified, then DOM node viewbox.value, sure. And look at that, so tidy. Or was that 4? It was 4, okay. So that's really nice. Okay, so let's see if this actually works. Also, this layout attempting to lay out indefinitely sized SVG, blah, 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 this spam stuff. I think if we implement this correctly, then we should be able to remove that. Crashed. Cool. All right. Let's get a debugger and try that again. Oh, okay. It looks like I have a infinite recursion. That's nice. So compute width for replaced element calls tentative height for replaced element, which calls compute width for replaced element. Cool. So compute width for replaced element calls tentative width and tentative height also here. Okay. So I think we're gonna look what the spec says about this. So CSS 2.2 is where we find this old stuff like block level replaced elements. That would be under visual formatting details. Block level replaced elements. The used value of width is determined as for inline replaced elements. Okie dokie. Okay, so this is 10.3.2, 10.3.2, right, inline replaced elements. And we have an inline, well, we have a block level replaced element with auto width and auto height. So let's see, we have both have computed values of auto, and the element also has an intrinsic width. We don't have an intrinsic width. In our case, we just have a view box, right? This thing does not have a width or a height, it just has the view box. So we have an intrinsic aspect ratio, but we don't have any other intrinsic sizing properties. Okay, so height width, both auto, no intrinsic width. So not this case. Height width, both computed values of auto, and the element has no intrinsic width, but has an intrinsic height and intrinsic ratio. But we don't have an intrinsic height, so it's not this formula either. If height and width both have auto, and the element has an intrinsic ratio, but no intrinsic height or width, that's us. Then the used value of width is undefined in CSS 2.2. However, it is suggested that if the containing block's width does not itself depend on the replaced element's width, then the used value of width is calculated from the constraint equation used for block level non-replaced elements in normal flow. Right, so they are referring to the stretch fit size, I'm pretty sure. Okay, so what am I looking at here? Compute width for replaced element. If width is auto, so I feel like this isn't really written correctly entirely. So it should be, if height and width are auto, but the element has an intrinsic width, then we should use the intrinsic width. So where does it, I was just thinking, where does it apply the min-max constraints? I guess I guess that's later on in the, whoever calls this is responsible for constraining by min width and max width. So let's see, let's start with this then. Okay, so if height and width both have computed values of auto, computed height, then return the intrinsic width. Wow, thank you, Copilot. And then we have this slightly larger one where we do multiply the used height by the intrinsic ratio. Okay, so Oh, this logic is in this function, tentative width for replaced elements. So wait, so I'm doing stuff that's already exists. Okay, back up. So the logic I'm trying to replace is in here, tentative width. Wait, so where is this from? The tentative width. Okay. Oh, this is the logic for min width and max width. I'm looking right at it and saying that it's elsewhere. Right, so the tentative width is the algorithm here that we were just looking at. Where is it? Here. This is the tentative width that we're calculating. And then these are the application of the min and max constraints. Okay, so let's look at the tentative width. Tentative width. If height and width both have computed values of auto, blah, 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 then we should use the used height. Let's see if height auto, the element has no intrinsic width, but does have an intrinsic height and intrinsic ratio. Is that really what this says? Height auto width auto intrinsic, no intrinsic width, but intrinsic height and intrinsic aspect ratio. That's the first case. Or if width has auto, height has some other value, and there is an intrinsic aspect ratio. Oh, here is the case that we were supposed to implement, and there's nothing under it. Right. So, okay, so this is where we put our little new thing. So height is auto. There's no intrinsic width, no intrinsic height, and there is an aspect ratio. Yes, exactly. Then we should use the stretch fit width of the box. Calculate stretch fit width for the box with the available space. I think just the available width goes into that, no? Non-static member function. Oh, this is a static function. Okay, so we need to make a static variant of the stretch fit functions. No problem. We'll just do that. Some of these functions, some of the functions in the formatting context code are static so that they can be used as helpers, which is a little bit weird, and I'm not sure that it's a good pattern, but it is how some of the code is laid out at the moment. So let's go and just make these old ones be wrappers against wrappers around the new ones. Like that, and then we use state instead of taking the member. Thank you, Copilot. All right, and then let's see, state. All right, there we go. So now we can calculate stretch fit from the tentative width thingading. All right, so here we just need to pass the state that we have. Okay, so what happens if I just do that? Is that enough to solve my problems? I wonder. It is not. Okay. Let's see. We're probably still crashing in the same place. I didn't really look properly what was happening, but at least now we know that we have implemented the tentative width for that thing. So who was calling us here? So I think this will be compute width, line 450. Yeah, it's this call right here. So we have computed width auto, computed height auto, and an intrinsic aspect ratio. What is going on with that? Why are we trying to calculate the height here? So what did it say when we search for this? Tentative used width. Following the rules under calculating widths and margins above. Yeah, we calculated the tentative used width. That's what we did. What is this thing? Solve replaced size constraint. So why are we using tentative height for that? That nobody mentions that we should do that. What if we just use I was going to say, what if we just used a used height? Or is the problem that this thing here is calling back into tentative width, maybe? Let's see, what is that thing doing? 489. So here it's calling compute width for replaced element. If height has a computed value of auto and the element has an intrinsic ratio, then the used value of height is used width divided by intrinsic ratio. But we're not taking the used width here. We are taking we're calling the function that computes the used width. What we should do, since now we're asking about a height. So I think by the time we're here, we always, almost always. I think in the context of replaced elements, we always calculate the width before the height for replaced elements. I'm not sure if that's true in Flex layout, actually. But I think in this case, we should do what it says and just take the used width that we have, which would be just asking for the box's content width in the current layout state. Okay. And what happens if we do that? Okay. So now we're up and running again. And that's interesting. So it resizes up to a point, but then it doesn't want anymore. Okay, so this is progress at least. So this should mean that if we put a border on it, I'll put a juicy 5-pixel border here. Yeah, so it is resizing along with the SVG. Although we're not quite doing that correctly, as you can see, because the margin on the right side is missing. But let's ignore the margin on the right side at this point, because that's a detail somewhere else. This is great progress. So our SVG box is now almost entirely correctly stretch fit sized. Although I wonder if there's a bug in the stretch fit width that is super obvious. Subtracting margin left, margin right. I don't see the immediate mistake there. Okay, so ignore that. All right, so why does it render so weird? And what happens if I switch the display to inline at this point? That's really odd. So if we switch it to inline, then now it also, because the inline code will just call into the same sizing function that we were just editing. So the size of the SVG box is not correct, although the contents of the SVG are not really updating to match the size of the viewport. So why is that? Let's see how, I know where the inline formatting context has this thing called dimension box online, which basically figures out dimensions for each box and then inline context one at a time. And we do this thing here. Yeah, it's hard-coded. Like if this is an SVG box that we're trying to compute size for, then we have to perform layout inside of the SVG box. And now that I look at this, what stands out to me is that we lay out the inside of the SVG box before we compute how large it is. So how could it size the innards to fit the outside? So what if I did that? Calculate the size before laying out the inside of the SVG. Let's see. Yes, that is nice. All right, that's exactly how it should behave. Now we are matching Firefox for inline. For block though, for block we're still a little bit wrong. Okay, so that's good. So why does it behave this way? I guess we need to tell it how large it is before doing the inside layout in the block formatting context as well. So in the block formatting context, when we are doing layout of a block level box, then it's not floating. Here we run the independent formatting context, and I wonder, what does the SVG formatting context say? Let's see what the inputs are. So running SVG formatting context with available space. Okay, so when we're running the formatting context, we have a definite width, but we have an indefinite height. Interesting. So if I switch back to inline, then we always have a definite height as well. So that might be the key. So we need to make sure that that when we run the SVG formatting context, we need to have a height assigned. So normally for block layout, we the order of operations is typically first we figure out the width of something, and then we lay out whatever is inside of it. And based on that, very often we figure out how tall it is, because you might have like, if you have a block that has a bunch of text in it, you have to lay out the text, split it into lines before you know how tall that block is going to be, if the height is auto. But in this case, we know beforehand how tall the box is in this case, because I mean, compute height is here, but we could do it earlier. What if we just did it earlier also? I wonder if that would screw something up. Let's try it. I feel like that's gonna screw up other stuff though. Okay, yeah, so if we do that, then we get exactly the good behavior. But yeah, it breaks breaks other things. Like this test is apparently different. Okay, so it breaks margin collapse, apparently, in some way that I don't want to debug. And it's also just not like the right thing to do in normal block layout. But for replaced layout, like for replaced elements, I think this is always safe. So if the box is replaced box, what if we said that? Like we always try to compute the replaced height immediately here. I think that would be okay. And then maybe we could even not do it afterwards. I'm just gonna do it again afterwards because that shouldn't hurt anybody for replaced elements because it should always get the same results. And then does that break anything? It breaks an SVG test I made earlier today. How does it break? It breaks it because I guess it just gets different dimensions. But the point of that test was just not to crash, so it doesn't matter how it's laid out. Although now it actually looks like the way I imagined it when I was writing the test, which is still apparently not correct, but the point of the test was not to crash, so I don't care what it looks like. That's fine. We will just rebaseline that test and see if we broke anything else. Hey, okay, we made it to the end. Fantastic. So the moment of truth. Does this fix Shopify? It does. Hey, look at that. Okay, so now it's in the right spot at the right size. Looking a little bit jagged, of course, because our path rasterizer is pretty jaggy. That's one of those long-standing things that we're eventually going to fix, but not what we're here to do today. So that's fantastic, though. Makes me want to test another website. I know that the tuple app has SVGs on their front page, but these are IMG tags, so they don't show up yet. That's a whole other problem. But I think they have inline SVGs here. Yeah. Like this Mac and Linux logos I think we couldn't see before. So that is pretty sweet. This transform here doesn't look very good. And we got some arrows here looking really weird. Oh my goodness, look at that. That's such an awkward looking circle. Yeah, we have to fix the rasterizer at some point. That's supposed to be a circle, I think. I was just downloading tuple the other day. Yeah, this is what we're supposed to be. This is the U versus the path rasterizer she told you not to worry about. But I'm pretty sure that we couldn't render any of this before. Let me just double check that. Dun, dun, dun. What if I just git stashed? And then I went to tuple.app. Okay, maybe I was wrong about this. Oh, maybe they worked all along. All right, my bad. Anyways, that we still have to fix how ugly they look. Just not right now. All right. So this is all very nice. Just gonna go and admire. Okay, so this definitely is the before picture. And git stash pop is gonna be the after. And also all of this spam here actually goes away now, because the SVG is no longer indefinitely sized when we're doing the layout. So just the new spam that I added, of course. The running SVG formatting context. It feels good to be actually working through and like getting rid of debug spam, because it's pretty spammy. And now we're almost down to, it's like almost all just, oh, I loaded this JS file, I loaded that JS file. I think these are open type rasterization errors. So we're probably screwing up some text glyph somewhere. We have some non-finite intrinsic sizes. Yeesh. All right, a bunch of buttons getting infinite size. That's something to look into. But yeah, this is fantastic. And just making a little bit of progress, a little bit every couple of days. And there's still a bunch of stuff to do. Oh, these SVGs here at the bottom showing up properly now as well, actually. That's really nice. Meet the people who choose. I feel like that's supposed to be like one of those background clip tricks. Yeah. Clipping the background to the text. That's going to be an interesting thing to implement. But yeah, if you don't clip, I'm pretty sure there's a background clip text. Yeah, background clip text. If you turn that off, they also get the thing. That's such a cool CSS feature. Definitely going to be a bit of a hassle to build because we don't have arbitrary path clipping. But we'll figure it out. Anyway, let's make a test and a commit so that we can turn this into something useful. So did I add a bunch of debug logging? I didn't. And it's pretty much all one big nice change. That's very cool. So the test I want, I guess, is I just want to have an SVG and then make it display blocks, and then see that it stretch fits sizes. So I guess, I mean, why can't I just use the one I just used? Maybe I'll just edit it down a little bit because it has a bunch of things that I don't need. Don't need you. Block. All right. So yeah, that's really cool. Maybe that can be the whole test. Test libweb layout input SVG SVG with display block. Okay. And I wonder, did I need to set a font for that? No, because it's all block level stuff. So there's no font metrics screwing up my test. Good. Okay. libweb. Let's see. So implement. Actually, let me just make sure that I didn't screw up our existing SVG demo, because we do have like this old one that we've been using. SVG. It still looks the way that it always did. Okay, good. Support SVG SVG elements with display SVG elements. Yeah, I guess that's what I should say. Okay. I'm hesitating sometimes to use tags here because I know it screws up the there's like a markdown parser or whatever in Discord, and we have this thing where Git commits end up in automatically posted to Discord, and then the formatting gets screwed up if you use tags sometimes. So I'm hesitating to use them for that reason, but that's stupid. So let's see. So there are a couple of things going on here. So there are a couple of things that went into this. Now implement calculate the intrinsic width, height, and aspect ratio of elements based on the spec algorithm instead of previous ad hoc guesswork solution. Replaced elements with a stretch fit. Replaced elements with width, auto, height, auto. Replaced elements with automatic size and intrinsic aspect ratio, but no intrinsic dimensions, are now sized with the stretch fit width formula. Yes. We take care to assign both width and final width and final height both used width and used height to SVG elements before running their SVG formatting contexts. This ensures that the inside SVG content is laid out with knowledge of its viewport geometry, let's say. Okay, was that the whole thing? We also had to fix an infinite recursion in tentative height for replaced element. With infinite recursion and tentative height for replaced element by using the actual used width instead of the already calculated used width, instead of calling the function that calculates the used width, since that may call us right back again. Okay. I think that was the whole trick. And then I forgot to add everything to it, so let's do that. And no, that's excellent. I think that's a good description of what we had to do here. So let's see. I am really pleased with it. Sorry, I just had to snap out of it there after being in the commit message writing headspace. This is so nice. Yet another little visual progression. All right. What will be the next one? Who knows? But I think that'll be it for today's video. So if you made it here, thank you so much for watching, for hanging out. I hope that you saw something interesting today. I'm certainly enjoying being back on YouTube and doing my favorite thing in the world right now, which is improving the way that things work in Ladybird. It's just so satisfying. So thanks for hanging out with me, and I will see you all next time. Bye.